Carbon is the basic building block of life, and these unique atoms are found everywhere on Earth. Carbon makes up the Earth's plants and animals, and carbon is also stored in the ocean, the atmosphere, and the crust of the planet. A carbon atom could spend millions of years moving through the Earth in a complex cycle. Understanding the carbon cycle and how it is changing is key to understanding Earth's changing climate. On land, plants remove carbon from the atmosphere through photosynthesis. Animals eat plants and either breathe out carbon or it moves up the food chain. When plants and animals die and decay, they transfer carbon back to the soil. Moving offshore, the ocean holds huge amounts of carbon, about 50 times the amount we find in the atmosphere.
The ocean is sometimes called a carbon sink, meaning that it absorbs or takes up carbon from the atmosphere. It takes up carbon through physical and biological processes.
At the ocean's surface, carbon dioxide from the atmosphere dissolves into the water. Tiny marine plants called phytoplankton use this carbon dioxide for photosynthesis. Phytoplankton are the base of the marine food web. After animals eat the plants, they breathe out the carbon or pass it up the food chain. Sometimes phytoplankton die, decompose, and are recycled in the surface waters. Phytoplankton can also sink to the ocean floor, carrying carbon as they descend. Over long time scales, this process has made the ocean floor the largest reservoir of carbon on the planet. Most of the ocean's nutrients are in cold, deep water. In a process called upwelling, currents bring nutrients and carbon up to the surface. Carbon can then be released as a gas back into the atmosphere, continuing the carbon cycle. By cycling huge amounts of carbon, the ocean helps regulate climate.
So when you think of climate, you don't often think of the ocean. Climate, you think of, is it going to be hotter this year? Is it going to be colder this year? But the oceans are actually a great regulator or controller of the Earth's climate. And they even are controlling how much carbon is in the atmosphere, which can slow down how quickly climate change is occurring.
At the most basic level, the balance between incoming sunlight and outgoing heat determines the Earth's climate. Greenhouse gases act like a blanket and trap heat in the atmosphere. Carbon dioxide is a greenhouse gas. In the past 2 centuries, humans have increased atmospheric carbon dioxide by more than 30% by burning fossil fuels and cutting down forests. The Earth has not experienced carbon dioxide levels this high for the past several million years. Researchers are learning that future climate change will depend on carbon levels in the land, in the atmosphere, and in the sea, and how these levels respond to human disturbance. About 1/3 of all human-generated carbon emissions has dissolved in the ocean. More than 80% of Earth's added heat is now stored in the ocean.
In the future, as the planet gets warmer, the water's going to warm up, and warm water can hold less carbon than cold water. The other thing is, on a warmer planet, some of the currents are going to slow down, and so we might not be forming as much of this cold, deep water. So we won't be able to transport carbon into the deep sea. So on the whole, the ocean's going to become less effective at removing carbon from the atmosphere.
Throughout most of Earth's ocean, the warmer water, weaker circulation, and new temperature gradients that result from climate change will impact marine life and ecosystems. These changes affect the ocean's ability to store carbon. Increased carbon dioxide in the atmosphere impacts marine life in other ways.
As the ocean absorbs more carbon dioxide, it becomes more acidic, and this can be a threat to some of the organisms that live inside the ocean.
As Earth's climate continues to change, how will researchers monitor something as big as the ocean and something as complex as the carbon cycle? NASA Earth-observing satellites give scientists the big picture view of our home planet. Varied satellites help researchers detect changes in ocean climate and ecology over time, providing vital insight into the health of our home planet.